3. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Um, Today we are going to present about our problem-based learning, that is PBL, regarding the topics of DC converter for solar application. Okay, my name is Muhammad Afiq bin Jamari.
And my name is Mama Afizi bin Anwar.
We are from group A3, going to present our result based on our experiment. First is introduction.
Okay,
Okay.
introduction about DC converter for solar application. Okay, what is solar? So, solar is a renewable energy that receives tremendous demands since it pollution free. So, why we pick solar? Solar is advantage of solar energy is not only we can get the source of energy for nothing, but it's also safe and clean for environment. Okay, how it's work? So by using solar, battery are need so that the supplying of electricity will be continuously. And then what is DC to DC converter? DC to DC converter is a type of electrical converter that convert DC current from another level to another level. And then where it be used for DC to DC converter? So it used widely in renewable energy generation system such as solar photovoltaic system.
Next is problem statement.
Okay, for the problem statement, what is problem statement is you work as a design engineer in a solar company and you are required to come out with a DC-DC converter that is able to maintain the output of 12 volt solar module regardless of the weather condition. As for initial stage, and only an open loop system is required. However, the design should produce a constant 12 volt with peak to peak ripple voltage of less than 1%, and the converter must operate in continuous inductor current mode under all conditions. From several testing, the solar module produce voltage that varies from 10 to 17.6 volt, with the current varies from 5 to 7.39 ampere respectively. So next is for Afiq Jamari.
Methodology. Okay, I'll be presenting about methodology, which is our circuit design. Okay, based on the figure that I have shown, the circuit is the circuit design for the DC-DC converter for solar application. This solar module, two resistor valued 10 ohm and 2 ohm, two capacitors value the 270 micro and 50 micro. So one inductor value 220 micro. So a diode, square wave voltage source, and a MOSFET. So the solar module was connected to a sumption irradiation of 1200 and a temperature of 68 degrees Celsius. So where this is only the assumption of whether that the student choose or made. So the 15 microcapacitor is connected in parallel with the solar module to increase the waveform of the V in and I in, together with the resistor of 2 ohms. The boost converter circuit we use in this design consists of 220 inductor, 20 microinductor, diode, 270 micro capacitor, and a MOSFET. So the function of boost as the output load, so that the waveform will filter. So the using of resistor as load affect the voltage output, as it will make the voltage output constant at 12 volts. Okay, next I'll be talking about the result and the simulations. Okay, here are the results that we gained for this experiment. So this is a table that shows the average V in, V out, I in and I out of our experiment. Okay, and this chart is actually the relationship between the temperature that is temperature here and respective to the V out. V out. Okay, so I'll be showing the simulation. Okay, here are the simulation, how it is done. Okay, first, as you can see from the table before this, we have to set up the irradiance and the temperature. So this is the irradiance. Okay, first I will set up at 100. Okay, and this is the temperature. So I will set up at 28. Okay, and together we must set up at the solar module 2 the same value. Okay, after we have set up the value that we are needed, okay, we just need to run the program. Okay, so this is the output result that we're going to watch. So first we click V in and V out. Okay, this is the waveform, which you can see is constant 12 voltage, 12 volt for our V out. Okay, so now is the I out. Okay. Okay, this is our current V out, V in, V out, and I in, I out. So how we get the amount that we need for the table by clicking measure. Okay, so they give out the average value. That is this, all this. Both. Okay. So our experiment, we are testing the irradiance of from 100 irradiance with 28 degree temperature until 1200 irradiance and 68 degree temperature. Okay, that's it from the simulation. So back to the slides. Okay, lastly, the conclusion. Okay, as we know, the conclusion states here that students are able to design a DC-DC converter that meets certain requirements, as it was given and it was tasked to all of the students that are undergoing this PBL session. So other than that, the students also able to set up an experiment to analyze the performance of the DC-DC converter. And last but not least, the student can assess the performance of the DC-DC converter, which means the performance of the DC-DC converter. Okay, that's all from.
Okay, thank you.
Thank you.